Okay, everyone, this unit is on relating graphs to events. It's very important in these units that you remember that this is simply a graph relating the x-axis, in this case time, with the y-axis, in this case meters, relating the distance you are from your homeroom to time passing in minutes. The x scale I've changed so that it's actually each notch being a 10-minute increment. So if you were to draw a picture of you going from your homeroom to your next class, like on a map, it might look similar to this, but it will look decidedly different in some respects. For example, if you started out in the morning, you were in your homeroom, your distance from homeroom would be 0. So you should notice that you start out, if you call the first minute of the day minute 0, you will be 0 distance from your homeroom. And as you sit in homeroom, time will be passing, and if you're there for 10 minutes, the line will have a slope of 0 because the change in your distance from your homeroom is 0, and you remain 0 feet from homeroom because you're in it for a full 10 minutes. At that point, you walk off to your first period class, so that would be 10 minutes out. At 8:10, you move to your first period class. If you went all the way out to Tony's room, that might be pretty far. Let's say you're 10 meters away. So you go to science and you go 10 meters away, and let's say it took you a full 5 minutes to get there. It'll be hard to draw the steepness of this graph, but it would go roughly over just 5 minutes. In other words, half of one of these units, and you would go exactly 10 meters away. So it will be an extremely steep slope because you have moved a full 10 meters in 2.5 minutes. Now in reality, that's not that fast, but due to the scale of this graph, it looks like an extremely steep slope. If you're patiently sitting in science class the entire time doing your work, and you do not move, for that entire time your distance from your homeroom will remain entirely flat until you get about 50 minutes out, at which point you realize you need to go back to your homeroom cubby, and the graph would be a mirror, but it would be in a negative slope. So your distance from homeroom would quickly decrease until you got there, and let's say it took you a full 2.5 minutes to get there, and you got your pencil. Now, let's say you then had math, so your distance from homeroom would, for that period, again be 0 for another bit of time. After math ends, let's say you go downstairs to recess. Not as far as science, but again, positive slope. Sit down at recess, slope of 0. If you then walked your friend to the nurse, again, but your friend was very sick and it took you a full 10 minutes to get to the nurse, it would be, again, a less steep slope because you're just going so incredibly slow. In this case, it took 20 whole minutes to get to the nurse, very slow. And this would be a graph that shows your distance from homeroom. It is not a map. It's important when you get one of these graphs to recognize what is on the x and what is on the y, and what it will look like in comparison to what is going on in the real world. For your homework, you are going to make a graph with an appropriate scale and appropriate units matching the following events. There will be one graph, each with on XY axes, fully labeled for each event. The first graph you'll do is a graph of the tide coming in and out over the span of one day. Start your graph mid-tide and call that point 0 on the y-axis. Time always will go on the x-axis. Remember, this is over the span of one day. Choose appropriate units. The second graph will be the height of a tomato plant seedling which you bought at the grocery store or Home Depot or what have you, and you planted it in June, and the height of that seedling as it grows through its life cycle and into November. The last one has to do with a data challenge. It's the count of people in the math classroom from 7 to 7 on a common school day. This has an issue involving the kind of data. We covered different sets of numbers in the first unit. The sets of numbers that you might be able to use for counts of people would not be the integers. It would certainly not be fractions. You're not allowed to have fractional people. You're not allowed to have negative people. So the best set of numbers would be the set of whole numbers. When you graph the data of the number of people in a math classroom over time, you should not have 7.1 people in the classroom at any time. This data will jump when it changes from point to point. It may be totally constant at 7 people if there's 7 people in the classroom over time, but it will not move through the numbers 7.1, 7.2, 7.375, or any number that is not a whole number. It would simply jump from 7 to 8 or from 7 to 6 as people enter and leave the room.